Alright, nerds. So let's talk about ramps, or, as they are known scientifically, an inclined plane. So, one of the cool things that ramps do is they make it easier to go up a mountain. We could go straight up this mountain, this way, or we could go up a windy mountain road. So basically, it would take a certain amount of force to go straight up the side of the mountain. But if we go up a longer, windier road, it takes much less force to do so. The exact same amount of energy, so the same amount of fuel is required to get you from here to here, if your vehicle is able to do that. But we do this and it's a much easier way up the mountain. And it does this not by decreasing the amount of work we have to do, but by increasing the distance and thus decreasing the effort. So our learning goal is to be able to understand how ramps reduce effort, like most simple machines. And we also want to be able to, at the end, we should be able to explain using the correct vocabulary how an inclined plane gives you a mechanical advantage and how to calculate that advantage. So, what is an inclined plane? Here's a pretty good example of it right here, very basic. This is called a free body diagram. And we can see that if we want to lift our object here up to this level, we can go straight up, or we can move it up this gentle slope, basically. So ramps, or inclined planes, they make jobs easier by reducing the force, or the effort, required, and it does this by increasing the distance we're moving it. So instead of lifting an object straight up, it is moved a greater distance, which means it uses the same amount of energy. So here's a good example where the numbers all kind of work out to, tens and whatnot. So we can move this 1 kilogram object straight up 2 meters. That's entirely possible. And it would take 10 newtons to do that. Okay? Or we could use a ramp. Now, when we go up this ramp, we can see that the distance is no longer 2 meters that's going up, but it's 8 meters. Okay? So, how much easier is it? The force, what is it? Well, let's have a look. So, here we've got 1, 2. This is the work for number 1, which is moving us straight up. So, important to remember here, S equals distance. So work equals force times distance. And we're looking at the work for moving it straight up that 2 meters. So, it's 10 newtons times 2 meters. 20 joules. Alright, cool. Because of the law of conservation of energy, we know that to move it up this one, number 2, the work is still going to be 20 joules. The force is what we don't know. How much effort are we going to have to put in? And we're moving it 8 meters. So, we rearrange it, and that gives us 20 divided by 8. So, if this is multiplication, then we divide both sides by 8. That cancels out that side. And that leaves there. So force equals 20 over 8, or 20 divided by 8, and it's 2.5 newtons. That is a much, much smaller force than going straight up. So we can see that the ramp has made it easier. But what is the advantage of using a ramp? So, mechanical advantage is, as we know from earlier, is a ratio. So we have force 1, that's this one here, divided by force 2. That's that one there. And it's 10 divided by 2.5 is 4. And to show you that it's consistent, if we make it 8 meters divided by 2, it's still 4. So, while we're at it, what is a helically inclined plane? You might know that as a screw. A helically inclined, I just said that. And they work basically by decreasing the amount of distance that it has to go, increasing the distance it has to go in. Alright, it's a much easier way to get your screw into the wood. And same reason with the mountain road. Okay, so the mountain road is easier to travel up when it's a windy mountain road than when it's straight up the hill. And that's because we're traveling further, like all other ramps, and so less effort is required to get there in the first place. Okay, so I hope that made a lot of sense. And if it didn't, put your questions in the comments below, and we'll get back to you as quick as we can. Thanks for watching. See you next time. Bye now.